In this video, we are going to find the longest common prefix string among an array of strings. Hello, I am Jagan from Grow with Data. I am posting this video to share my knowledge in Python language with you. If this assists you in interview preparation anyways, I will be happy. Let's see a sample input data and we can talk about the question in detail. So we are given a list of strings. For example, we have the input as strings which has three input: flower, flow and flight. If you see, the longest string which is common in all three is F and L, which is common in all the three. If you go to the third character, then the first two will match but the third one is not. So the expected output is going to be F and L. Okay. So this is what we are going to try. So before we start doing this, let's refresh our sorting function. So if we say sorted of strs, what will happen? It will sort based on the lexicographic, like the alphabetical order, right? So first it comes with F, L, and then I comes first, and then O, and then within O and W, and then comes E, right? So it just ordered based on the alphabets. If I want to change the order based on the length, then I say key equal to length. So if I do that, then the string will be ordered based on the length of the string. Okay, fine. Now we are going to start with our coding part. So let's delete this. Let's start with the function grow with data, the input value, and first thing what you do is we have to loop in every string and every character, right? So for that we have to know how far we have to loop in, the minimum length we have to loop in, right? So we just say minimum length equal to, we just do for yes in the input string, we get every string, we just get the length of the string, and from that we get the minimum length. Okay, so let's see what this returns. So we return the minimum length and see if it's return 4 or more, right? So the smallest string is flow, which is of length 4. So we are getting the minimum length here, but this is not what we are required. So to find the longest prefix string, we just have a variable result as a blank string, and then we are going for our looping function in range minimum length. So if it's 4, it starts with 0 to 3. So the first character we are going to look for is the input list first string, and then whatever the range is. So first time it will take the flower, and then I equal to 0, so F will be here. Okay, the character will get the value F. So we say if S of I, what is S of I? We are just going to do it equal to whatever the character is for S in strs, right? So what we do, we get every string from the list and we get the position of that string. Like if I is 0, that means we get F from all the string, and we see if it's matching with the first characteristic, the first one we are taking here, right? So matching with that. So if that is the case, then we just say if it matches everywhere, we just add to the result plus equal to here. If not, you can just break. And then we are going to return the result here. It's bringing flow. So where are we missing? So we are getting the minimum length for I in minimum length 0 I. Oh, okay. So here we have to find all, right? So if this will bring true for one and false for others. If you have checked for one true, then it will just pass. So the all the string has to pass the condition, right? So we have to put all. So you put all, then it will get the each character which is common in all the three strings of the given input. Okay, so this works fine. So let's fix few more things here. First one is the edge cases. So what happens if the string itself is blank, right? If not strs, then we can just return a blank string. What if the input list is having only one string, right? We just say if length of strs, okay, the length of the input string equal to 1. 1 means it just brings in only one string. Then we can just return the first element of the string, right? So this is other two edge cases came to my mind when seeing this. So if you want to have additional test cases, then as we always do, use the assert function and bring in here. So this is what we check: the flower, flow and flight. The first two letters are common, FL. For these three characters, nothing is common, so we just return a blank. So when the input is blank, then we return a blank string. When we have only one string, then we just say bring that. If there is any two which is not having anything common, we just put blank. Okay, so this pass all the test cases. That's good. So this approach, it iterates through the character of the shortest string in the list and check if the same character exists in the same position in all the strings. So it accumulates the common prefix character into the variable called result. It's easy. So if you see the time complexity of this code, we can say the time complexity is depends on the two things. Let's put it here. So the first one is the variable n, second one is m. So n represents the number of strings in the input. So here it's 3, right? And the m represents the average length of the string. So here what we do, we are getting the first character here, and then it goes till the shortest length of the string. In the worst case, it checks each character of each string in the list until it either finds a character mismatch and breaks, or it goes till the end of the string, right? Therefore, the time complexity is going to be O of n slash m, right? So n string, it goes till the shortest length. So O of n cross m is going to be the time complexity. Okay, now we can try with another approach. So we iterate and compare with the shortest string. We just take this and we move on to our, oops, sorry, this pass is gone. Oops. Okay. So the second one, we just use the edge cases here, and then what we are going to do is we are going to sort the input string. So before we start the exercise, we just talked about the sorting. So key equal to length. So what will happen? The string will sort based on the length of the string. Okay, we use that, and then we have the result variable as a blank one. So what we do, first we get the index val in e. So we take the shortest strings flow. So we get the flow as the first variable here, and then every character of the shortest string. And then we just say the sub index and sub val in enumerate starting with the 1. Okay, so the first string we take it the first loop, and the second string we are taking from the second loop. We just say the match equal to true by default. Now we are checking if if the val is not equal to the subval of the index position. Okay, then we say match equal to false and we break. So what we are doing here, we are taking the shortest one here, so it takes the flow, and from here it takes the other two values 1 2 3 6. So hopefully it takes flower and then flight. Okay, so the second one starts here. So here it takes f first and check from this string the index of 0 if that matches with f. If it's not, then you break here, but here it matches. So if it matches, then what we do, we go through the other strings, and at the end if the match is true, right, we just say result equal to that string, and then it goes to the second variable, so second character of the first shortest one, and then loop in f l and then o, it will come here, don't match, it breaks here. Okay, so if it's false, then we just break, return result. We have to call the function, which we haven't done. So it brings in f and l. Let's try with all the other edge cases. Okay, so it passed all the values. So what we are doing here, this method, we just sort the string based on the length, and we perform an iteration comparing between the characters at the corresponding position in the string, from the shortest one to the other strings. So from the shortest one to the other strings, and it checks if it matches. If it matches, it increments. If not, it just breaks. Here if you see the time complexity, same, if the n is the number of strings of the input and m is the length of part of it, then the first main thing is we are doing a sorting here, right? So for the sorting part, the time complexity is going to be O of n log n, right, based on the length. So the first iteration loop, we are getting the first string, so that is going to be, cost is going to be O of m. M is the length of the string, and the second for loop, we are getting the rest of the string, and then we are looping in. So that's going to be O of n minus 1. So therefore when you compare all this, the time complexity is going to be O of the m into n minus 1. Okay, that's the complexity for this approach. Sorry, we have log n also, right? So we just say O of n log n plus this m n minus 1. So this is the time complexity for this approach. Okay. Now we go for the third one. We do the end-to-end comparison after sorting part. So we just do this part, okay, and we sort based on the string alphabetical order. So we are not going to do the lengthwise, we just do the alphabetical order. Instead of results, we just put a integer default to 0. Okay. So here what we do is we just have the variable first, which is strs of 0, and the last is going to be the last string of the input variable. So let's have here. So if you say sort strs equal to sorted strs, so what happens? It will sort based on the alphabetical order, right? So it just start fl, and then third one is the smallest one I, and then O, and then O. Okay. Now if you say strs of 0, it will get the first flight. If you get strs of -1, it get the last. Okay. So just say print strs and str of 0 -1, you can see the order. So 0 will get the first one, -1 will get the last one. So this is what we are trying here. The first one is this and the last one is this. Now it's very easy to compare. We just say while I is 0 is less than the length of first, right, and I is less than the length of last, and this is the usual comparison we did. The first string's position and the last string's position are the same. We just increment if it's same. When you return it, we just say the first positions till where we find the match. Okay. So instead of looping in all the strings, what we did, we just took the string, did alphabetical order, so that Python itself will do the sorting part based on the characters, and then we take the first one and the last one and check every character matches. So if there is a mismatch, then the sorting itself might have fixed it, right? So we compare the first and last and make sure the length is within the shortest one and the characters are matched. If it matches, we increment the position and then we take that string and we just repeat it, right? This is the easiest way. So here what we did with the time complexity, mainly we go with sorting, which is O of n log n, right? After sorting, we are just comparing every character. So it's going to be basically O of m. Worst case scenario, it goes till the length of the shortest string. So when you compare this n of log n and plus m, basically the final time complexity is going to be O of n log n. So we have three approaches. First one, we haven't sort anything, but we just did the looping of the whole string. So the complexity is going to be O of n into the shortest string's length. The second one we sorted, and then we took the first string and we compared every character with the other strings, and the complexity is going to be n log n for sorting, and then m into n minus 1. And the last one, the main thing what we did is we just sorted, and then we find the first and the last, and we compare the characters, and we just brought in. So we can try all the test cases and then check how it works. It all passes. Hope you like this video. Thanks for watching.